Hello everyone. So today we'll be looking at a question from the trees section of cses. It is called subordinates. That's the first question from the trees section. Uh, so we are basically given the structure of a company. So the first person is the like he's the root of the tree, right? So he's the head of the whole company. Uh, and then you have the other members. So let's say if the company has 5 members, so you have an array which has the direct boss of that particular member. So let's say if you have this array 1 1 2 3, so it means for the second member, because the first member is already given that he is the boss of everyone. So uh, from the second member we are starting. So the first member is actually the boss of the second one. For the third member also, first one is his boss. For the fourth member, second one is his boss, and for the fifth member, third one is his boss. So like if we try to construct a tree from this particular example, it would be something like this, that this would be the first person. Clearly 2 and 3 are his children, so 2 and then 3, and 4 is the children of 2, like 4 is the child of 2, and 3 is the child of, sorry, 5 is the child of 3, right? So this would be the tree. So what we need to return, we need to return the number of subordinates of each of the members of this company. So like for this particular test case, if I were to output, so for the first person there are 4 subordinates, for the second person there's only 1 subordinate, for the third person there's only 1 subordinate, for the fourth person there are 0, and for the fifth person there are 0. So this is the answer for this particular test case. Okay, so now let's look at the implementation and the logic behind the question. Right, so first we will look at the logic and then the implementation. Okay, so what we will do, we will use DFS, depth first search. We will use DFS, and the way to use this is that let's say if we have this tree, right? So can you see that for each of the members, uh, the number of subordinates is nothing but the subtree size, the size of the subtree. Like for 2, if you see, so this is a subtree, so this subtree size minus 1, right? So this is the size of the subtree minus 1. So we need to calculate this somehow using DFS. We'll do that. So like let's just take a bigger example to just make you understand this thing. uh, so let's say I take a bigger tree. Let's take this. So for 3, if I say, so number of subordinates of tree, for 3, what you will do, you will calculate this whole subtree size. So this is basically 6 minus 1. So yes, number of subordinates will be 5, and you can see, so it is 1 2 3 4 5. So there are 5 subordinates, right? So from there, you can directly say that how many subordinates a particular member will have. Okay, so let's just look at the idea. So how do we calculate the subtree size? We will basically run a DFS. We'll run a DFS starting from the source node, which is 1, and so from 1, then it will go to 2, right? And then it will go to 4, right? And then when we are done, like when you will be running DFS of 4, you won't have any children. Like DH4 does not have a child, right? It does have a neighbor, but it doesn't have a child. So therefore, and we will be only storing the children, right? We won't be storing like generally in case of a tree, what we do is we store the neighbors, right? But here we won't be storing neighbors. We will store only the children, right? So for 4, if you see, uh, like DFS of 4, when you will run, it doesn't have a child, so then it will again go back. So while it's going back, you will simply write in the code that your subordinates of 4 is nothing but uh, is like when DFS of 4 is done, then your subordinates of 2 will be updated. Like when you're going back, that will be subordinates of 4 plus 1, and in the subordinate array you will basically declare a vector where each element at the beginning will be 0, right? So subordinate of 2 will be taken as 1, and then when you again go back, right, then you will have 1 updated. So then subordinate of 1 will become subordinate of 2 plus 1, right? So basically subordinate of 1 will become 2, and then when you continue this particular DFS and it returns back, 2 more will be added, so your subordinates of 1, final answer would be 4, right? So that's how we will be uh, doing the code. Now let's just look at the implementation to better understand this. Right, so let's look at the input part first. Okay, so here we have taken the input. uh, if we look at uh, the example that's given here, so we have made this array called bosses, right, this vector, and we have pushed basically only the children. So like if this is your tree, if this is my tree, 1 2 3, okay, let's take the example that's given here. The example that's given here is 1 2 2 3. So like this is the first person, and then the second person is like the first person is his boss, and for the third and fourth, the second person is his boss, and the third person is the boss for the fifth person, right? So this is the implementation of this particular tree. So what you are doing is I equal to 0, I less than n minus 1. So for I equal to 0, what you will do, bosses of 0, so bosses of 0 is what, it is 1. So you're just pushing the index, because the index is basically the children, right? Because in the bosses array we have the bosses of the particular children, so the index is a child, and this particular input that we have taken is the boss, right? So therefore we are doing adjacency list of bosses of I dot pushback I plus 2, as we are starting from I equal to 0. So and this particular thing starts from 2 3 4 and so on, right? This is already written here, so therefore we are doing I plus 2 just to accommodate for that, right? Okay. uh, so this input part is understood. Then what we will do, we'll run a DFS, and as 1 is like the sole boss of the company, so therefore we are starting our DFS from 1. So 1 is our source node. Now let's just look at the DFS function. So I'll take an example and show you all the DFS calls one by one. So if okay, let's take the example that we assumed, that one only. So if this is your tree, as given in the example, so a DFS of 1, so first DFS of 1 is called, right? Okay, so the next call, the first child is 2, so then DFS of 2 is called. Then for 2 you will call DFS of 3 first, then for DFS of 3 you will call DFS of 5, right? Okay, now when you call DFS of 5, then you will look at the child of 5. So it has no child, so this whole thing gets implemented, right? And DFS of 5 is finished, because DFS of 5 doesn't have a child anymore. So here we call DFS of 5, so that is done. So then you will update this. So subordinates of node, so our node was 3, so basically your subordinates of 3 will become subordinates of 5 plus 1, and subordinates of 5, as initially all elements are 0, so subordinates of 5 is also 0, so your subordinates of 3 is nothing but 1, right? Okay, so then your DFS of 3 gets implemented, right? Because this whole thing is done, and 3 does not have any more children. So your DFS of 3 gets implemented, and then this thing is again updated. So this time your subordinates of 2 is updated, right? And what does your subordinate of 3 was 1, okay, and what does your subordinate of 2 become? So your subordinate of 2 is subordinate of 3 plus 1, so this becomes 2 now. Okay, so now it is 2. Then subordinates of, then basically your 3 DFS, that part gets implemented, and then it will call for the next child, which is 4, right? So your subordinates of 4, like when you will go to 4, so then DFS of 4 will be called. So the next call after DFS of 5 is basically DFS of 4. So DFS of 4 gets called, and yeah, 5 and 3 we have already have vanished. So then the next call is DFS of 4. So when DFS of 4 gets called, 4 again has no children, so this entire loop doesn't make sense. And then your 4 gets implemented, and then this thing again updates. So your subordinate of 2 is now equal to like this increments itself by, like, so it's something like this: subordinate of 2 plus subordinate of 4 plus subordinate of 1, and subordinate of 4 is already 0, so this is subordinate of 2 plus 1, right? So your subordinate of, sorry, subordinate of subordinate of 2 plus 1. So your subordinate of 2 is now 3, right? uh, so which is correct also, because this 2 has total 3 subordinates. And then you will get back to subordinates of 1. So subordinates of 1 will update itself to subordinates of 2 plus 1, which is going to be 3 plus 1, that is 4. So your final answer for this particular example that we have taken, now the first one, for this one specifically, it is 4 3 1 0 0. So at the end you will just print it. uh, I'll show you. Yeah, so we're just printing subordinates of I equal to 1 to n, nothing special. So, and yeah, this is the answer. I just done it in rough before doing this. So I think you guys have understood the explanation. Thank you.